Okay, so without a doubt, you've been talking about various applications of derivatives. There's different ways that you can apply derivatives. One of them is like related rate problems. But there's various applications for derivatives, and what we're going to do today is we're going to talk about something called Newton's method. Now, I've provided a formula here, and I'm going to get into it, but what do we use it for? Well, it's used to approximate roots of functions by utilizing derivatives. So there's the application of the derivative part that I was talking about. And so you may be wondering, well, what the heck is a root? Well, you've been dealing with roots for a very long time. So suppose I have a graph here, and let's say it's the graph of a parabola. All right, well, these zeros right here on the graph are the roots. Okay, so there's one root and there's another root. And so what happens is you can utilize this formula, Newton's method, to approximate these values. And believe it or not, if you're using some kind of like a graphing calculator, when you go in and find the zeros of a function on the calculator with those programs that it's got built in, it's actually utilizing Newton's method. Of course, the calculator has the ability to really hone in on that number and does a better job than maybe we might do, but we're going to get really close. And I think that you're going to see when we get through these problems, and we're going to do about 3 of them, you're going to see that we can apply this and come really close to what the actual root is. So let's go ahead and take a look at a few examples. So here's the first one. The first one says f of x equals 3x squared plus 2x minus 1. And we set it equal to 0 because we want to know the roots. And we want to know the root centralized around the number 1. Okay, so if you look at the formula, and I've got the formula here, and I'm going to highlight around it. All right, there it is. It says x sub n plus 1 equals x sub n minus f of x sub n over f prime of x sub n. Now, what's not written here are in the instructions for this problem is that we're given x naught equals 1. They want us to find x sub 2. Okay? So we're going to go that far in to find x sub 2 in order to find something that might be close to the actual root, near or in the ballpark of 1. Okay? So what we're going to do is we've got the function. It looks like we need the derivative of the function. Okay, so we're going to find the derivative, f prime of x. All right. And so that's pretty easy. Derivative of 3x squared is 6x. The derivative of 2x is 2. Derivative of negative 1 is 0. So now I've got those two pieces of information. Now I need to find this f of x sub n part right here. Okay, so I've got to find that. So I'm going to need to find then f of x naught, all right, which is going to be f of 1. And then I'm going to need to find f prime of x naught, which is going to be f prime of 1. Now, this isn't too bad. It's more arithmetic than anything, and I think that it's easy to get lost in the arithmetic. So just be real careful here. So let's see what it looks like. We've got that. We plug it into f, and we get something like 4. And then we plug in 1 in here into the derivative, and that's not too bad. We get something like 8. Okay, so now we have enough information to find, let's see here, x1, x sub 1. So what is x sub 1? It is x sub 0 plus f of x naught, it's minus. It's minus. All right, because it's based on the formula, f prime of x naught. So now I'm just going to replace everything that I know. And I'm just writing it out, the formula out one time, and you'll see how it works from here on out. So x naught is 1 minus, and then we're going to have 4 out of 8, because that's f over f prime. So that's basically 1 minus half, which is just half. All right, so this is our x sub 1. And now that we know x sub 1, we're going to go and use the same method, and we're going to find x sub 2. But in order to do that, I need to find f of x sub 1 and f prime of x sub 1, which is going to be, in this case, f of 1/2 and f prime of 1/2. All right? And so we're going to plug in those numbers again into that original and its derivative. So let's go ahead and do that. All right. I'm just writing it out here, and I'm just going to tell you what those values are. So the first one is 3/4, and the second one ends up being 5. So to find x sub 2 then, I'm going to use x sub 1, and I'm going to subtract f of x sub 1 over f prime of x sub 1, and let's see what we get. So x sub 1 was 1/2 minus, and then we have 3/4 divided by 5. If you know anything about dividing fractions, I always tell my students to KFC. When dividing fractions, keep the first, flip the second, and change the sign. So that is 1/2 minus 3/4 times 1/5. So that's 1/2 minus 3/20. And you combine all of that, and you're going to get something like 7 out of 20. So 7 out of 20 as a decimal is exactly 0.35. And this is our x sub 2. So there's our answer. I'm going to leave it as a decimal. All right. That gives it a little more context. But believe it or not, I've actually worked these out on a calculator. I found the 0 on the calculator, and I'm going to give you the approximation, and I want you to see how good it is. So the 0 on the calculator is about a third. All right, 0.3333 repeated. So that's the 0 on the calculator. So it's actually relatively close. Newton's method's actually really nice. So you can imagine, maybe 100, 200 years ago when they didn't have calculators, they were doing this kind of stuff, and it's actually really neat. We have that calculator in our hand, and we take a lot of things for granted. But people with a lot less technology were doing things way more advanced than we do now. And they didn't have a lot of the tools that we have. They didn't have computers. They didn't have calculators. They didn't have a smartphone in their hand. So let's go ahead, review this really quick. I'm going to take a quick pause, and we're going to work on the next problem. Okay, so here is our next problem. We've got f of x equals negative x squared plus 4x minus 1. We're going to set it equal to 0. We want to approximate the root around the number 0. We're going to do this by finding our x sub 2 value. And so we're going to follow again Newton's method. So first thing we need to do is we need to take the derivative. All right, so we take the derivative. Let's see what we get. We get something like negative 2x plus 4. That's our simple derivative. Now we're going to find f of 0 and then f prime of 0. So that shouldn't be too bad. We're just plugging in 0. So you probably will figure out what those values are before I even finish writing them. All right. We've got that right there. Let's see here. This one, first one is negative 1, and the second one is a positive 4. And so now to find x sub 1, we're going to say 0 minus negative 1 over 4. What do we get? We get a positive 1/4 as our x sub 1. All right. And we're going to use that to find x sub 2. All right. Which is what we are really looking for here for this problem. All right. So in order to do that, we're going to have to find out f of 1/4 and f prime of 1/4 so that we can continue to apply Newton's method. All right, so let's go ahead and do that. Okay, so I've plugged my numbers in, and now I'm ready to evaluate these functions. You kind of do the math there, and you get for the first one negative 1/16, and for the second you get 7/2. All right, now we're ready to find our x sub 2 value. So x sub 2 here is going to be 1/4 minus, and then we have a negative 1/16 over 7/2. Again, You always remember when dividing fractions, KFC, that is keep the first and flip the second and change the sign from division to multiplication. Now we can do a little bit of reduction here. That's a 1 and that's an 8, and this becomes plus a positive. We end up with something like 1/4 plus 1 out of 56, and we can multiply this 4 or 1/4 by 14 over 14 to get a common denominator, or common denominator really. We get 14 over 56, which 14 plus 1 is 15 out of 56. Let me erase that right there, 15 out of 56. And when I do that on my calculator, 15 out of 56 is approximately 0.268, and this is our x sub 2 value that we were looking for. Let me box it in. That's our answer. And now let's see what it was on the calculator. So the 0 on the calculator, let's see how close we are. X is approximately 0.2679. Wow, how close is that? That is relatively close. It's in the ballpark. We are a lot closer on this one than in the last one, and it's all about precision here. We can keep going, find x sub 3, x sub 4, get really, really close and really minimize the error here and really approximate the value. But let's go ahead and take a look at another problem. Okay, so here is the next problem. It says x cubed plus 5x plus 2 equals 0. We're again trying to find the root, in this case centralized around the number -1. And we're going to do this by finding this x sub 2 value to get an estimated solution of the 0. If you know anything about the graph of this function, it actually only has one real solution, and that's actually the one we're going to be approximating. All right, so we first find the derivative, and let's go ahead and do that. We've got derivative of x cubed, 3x squared, plus 5. Derivative of 2 is 0, so we're good. Now we find f of -1 and f prime of -1 so that we can apply Newton's method. All right, let's do that. And let's see here. There we go. And now we are ready to evaluate these. The first one we get something like -4, and the second one we of course get something simple like 8. All right. Now we can find our x sub 1 value, and that is to say that we're going to have -1 minus, and in this case it's going to be -4 over 8, which ends up being plus 4 over 8 when you think about it. All right, so we end up having -1 plus 1/2, which gives us a -1/2 for our x sub 1 value. We're going to use that to find f of -1/2 and f prime of -1/2 to go ahead and apply Newton's method one more time to really hone in on that 0 root of this original function we're dealing with. Okay, so let's close that up. All right, here it is. Let's see what it is. Okay, I'm drawing a blank here because I've got so many things going on in my head. We're going to plug this in here like that. And then we have 3, excuse me, erase that. 3 times -1/2 squared plus 5. And what do we get? Okay, we evaluate those. In the first one we get -5 over 8. And in the second one, we get something like 23 out of 4. So if you're not particularly good with fractions, well, I'll say a prayer for you. All right, but it's just some simple arithmetic if you think about it. So to find x sub 2, we take our x sub 1, which is -1/2, and we're going to subtract, in this case, -5 over 8 divided by 23 out of 4. And again, when dividing fractions, always remember to KFC. I'm going to make those both positive to make it a little bit easier. We have -1/2 plus, and I'm going to have 5 out of 8 times, in this case flip the second fraction, 4 out of 23, and then we try to reduce where we can. This becomes 1 and this becomes 2 down here. We end up with negative 1/2 plus, and then 5 times 1 is 5, out of 2 times 23, 46. And then we can multiply this guy over here, the negative 1/2, by 23 out of 23, and we get something that looks like this, which is negative 23 out of 46 plus 5 out of 46, a common denominator. We get negative 18 out of 46. All right, which is about it is exactly negative 9 out of 23 reduced, which is about negative 0.391. This is our x sub 2 value that we're concerned with. All right, there it is. So what's the 0 on the calculator? All right, that's probably what you're really concerned with anyway. The 0 on the calculator. Let's see how close we are. So from the calculator function, the 0 on the calculator is about negative 0.388. So we are very, very close. I mean, it's one of those where they might say, well, it's good enough for government work, right? But it's very, very close. And in this case, you know, we're off by a little bit, but if you continue to find subsequent x values, you're probably going to zero in on what the actual root is. So again, a lot of solid examples here. I hope they were helpful and beneficial for you in applying derivatives using Newton's method. If this video was helpful, remember, like and subscribe.